Good morning, students. Today we are going to discuss about Schrodinger's wave equation. What we are going at as Schrodinger's wave equation, right? So in the previous class, we have discussed about de Broglie's wave equation and Heisenberg uncertainty principle we discussed, right? So there we discussed what de Broglie considered a particle, right, a microscopic particle as a wave. That is, as a matter he taken as, and the matter is made up of particles, right? Matter is made up of atoms. In the atoms, particles are there, right? So that particles they consider as a wave. He considered who de Broglie, right? In the same way, Schrodinger also considered electrons as a waves. Schrodinger also considered electron as a wave, right? So he considered that as a standing wave. How he considered as? He considered as a standing wave, right? How a standing wave will be there? Just we'll see a picture over there. Suppose this is the pathway. There is a pathway, and this is the nucleus. Suppose, right? So he considered as in this way. He considered. That means generally what is meant by a wave? A wave means what? What is meant by a wave? Which is having one crust at least. Which is having one crust and one trough should be there, right? Which is having one crust and one trough. If the two things are there, that we calling as a one wave, right? So if any wave is there, one trough will be there, one crust will be there, right? So now here see this, he considered electron as a standing wave, right? Now this is the pathway. This is the pathway. In that pathway, electron is revolving in a particular movement, in a particular way that is moving. Who is that? Electron, right? Electron is considered as what? A standing wave. Now you see this. Suppose here the electron is started. Electron is started its journey from there. Suppose electron is started its journey from here. Now he taken as what? Electron is moving from here to here, right? And then coming to here, right? Now you see this, one trough, one crust, right? One trough here, again one crust. This is one wave. One trough, one crust, another wave. One trough and another crust, another wave, right? Means what? The ending of the final wave, it is the starting point of the first wave, right? So this is the starting point. A trough and crust, again a trough and a crust. The crust of the final wave, that is ending point of the final wave, is the starting point of the first wave. That means here the energy is quantized. Quantized means what? Some amount we are giving, like 1 h mu, 2 h mu, some amount we are giving, right? So that is this mechanical model, this Schrodinger wave equation is like what? In this particular wave, it is having certain energy. How much energy is having? One wavelength, second wavelength, and third wavelength. Three wavelengths are there in this wave. In this, three wavelengths are there. That means you can find the energy of the wave, right? By a formula called E is equal to h mu, we can find the energy of a wavelength, right? So here three waves are there. That means you can find the energy, right? So that is, energy is quantized in the Schrodinger's wave equation. In no other theory energy quantized, but here energy has quantized. That is, here one thing we need to remember, electron he considered as a standing wave. That means this wave will be like this only. Again it will not change, right? So that is a standing wave. That means even the position will change. Now here the trough is there. Now it comes to here. Then it comes to here. That means the position will change, but the number of waves will be same. Then if the orbit size increases, if you draw one more like this, then the number of waves may be increases, right? Then here 3 is there, then there may be 4 or 5 or 6, right? So that is, energy is increasing as the size increasing and energy also increasing, right? So based on this Schrodinger's wave equation, there is another theory called the Bohr model, right? So based on this model only, Bohr has given one more model of atom, right? So that we will discuss further. Just you remember here what? Schrodinger's wave equation, he considered as a particle. He considered a particle as a standing wave. In the standing wave, the electron is having a wave motion, and in the wave motion, the starting point of the first wave is the ending point of the last wave. That means energy is quantized. We call it as energy is quantized. That means we are saying the particular amount of energy is there. Why? Because particular number of waves are there. If this wave is not connected here, if it is going somewhere else, you cannot find that how many waves are there, right? If it is coming to there only, you can say the starting and ending point of the wave. That by that you can say number of waves are 3, number of waves are 4, you can say it as, right? So by using that you can able to say the energy of the particle, right? So here what I am saying is that energy is in a that particle is moving in a wave motion, right? This wave motion is in a 3-dimensional motion. That wave motion is in a 3-dimensional motion, 3-dimensional motion, right? That means suppose you are taking this as a starting point, origin, then you can consider it as 3 axis, we can take it over there, right? So that is wave is moving vertically, and wave is moving horizontally, and wave is moving along through the z axis. That is x axis is moving, y axis, and in the z axis also it is moving, right? So that is, just imagine a 3D diagram of a wave. Just suppose any water source is there, suppose any water source is there. In the water source you are creating a disturbance. These all are water. Suppose you are creating a disturbance, then what happens? Waves will be generally develops, right? So waves are generating like this. Now you see that the waves are moving in this way and in this way also, right? And when you see them along through the level of the water, you can find that a level will be there like this, right? That means along through this axis there you find like a structures like this, right? That means what? Vertically, horizontally and vertically, and along with that z axis movement also is there, right? So that is we are calling it as 3-dimensional. That is, the wave is moving in a x axis, y axis, and in a z axis also it is moving, right? So based on this axis, based on these aspects, Schrodinger gave one equation that we call as Schrodinger's wave equation. What is that means? See here, dou square psi by dou x square. This we need to call it as dou, right? This is not like 6. Generally we have in math 6, no, that is not like 6. It is opposite to 6. That is we call as what? Dou square psi. That symbol is there, no? This symbol, this we call as psi. Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v psi is equals to 0. Right? What are there? Will just I'll tell you, right? So dou means it is not a mathematical expression, just it is a quantized value, right? How it will be means I'll tell you, right? Here psi is there, no? Psi, right? So that psi is a wave function. Psi is wave function. Wave function means, so this is a wave we are saying, no? Wave movement is there, no? How the wave is there, where it is started, where it is ended, how much energy it is having, with how much velocity is moving, what energy it is having. These all things we are saying, right? So that all things with togetherly we call it as a wave function. That all the things with togetherly we call it as a wave function. That means instead of saying a wave is starting here, wave is ending here, all these things, we simply say that psi. That means all the things about the wave, it is giving the information by the psi, right? Now dou square psi by dou x square in the x axis, along through the x axis, how the wave is behaving, that all things given by dou square psi by dou x square, right? And how the wave is behaving in the y axis, that is given by dou square psi by dou y square. In the z axis, how it is there, dou square psi by dou z square. And this is the particular constant value. So here 8 pi square into m means mass of the particle. Which particle we are taking? The mass of the particle. And h also constant, pi also constant, Planck's constant, this is right. And E means total energy of the system minus V, velocity, into psi is equals to 0, right? Again psi means wave function, right? So this is the equation given by Schrodinger, that we call as Schrodinger's wave equation. How it is derived, you leave it, that we will discuss in further classes. or else you don't need of that Schrodinger's wave equation. Just remember, if anyone asks what is Schrodinger equation, you just say this thing, right? And dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi is equals to 0. That is the equation. Sir, this is very difficult, sir, to be understand and to be remember. Means you can simply say this one in a short form. H cap, this is H cap into psi is equals to E psi. H cap into psi is equals to E psi. That is H cap psi is equals to E psi. Okay. So what is here H means? Here H is what? H cap is what means? Hamilton. That is the name. You don't get confused. That is the name. Hamilton operator. Hamilton operator. Simple. So what is Hamilton operator means? Here you are saying psi, right? For the psi you are multiplying all these things, no, right? We are adding, we are multiplying, we are doing something, all these things, no? Instead of writing all these things, we are writing H, right? Simple, right? So that means H means what? These all things we should do in the place of H. The value what we are getting, that we are taking here as a H, that is H cap psi is equals to E. E means the total energy of the system, and the again psi means wave function. And don't ask me again, here psi is there, here psi is there, in between that is equals to is there, H cap is equals to E, which will be, sir, it should not be equal. This is what we are giving the what we are calculating. This is what we are getting the answer. That is how much energy is there, that we are going to calculate. This is what, how much energy is there, right? That is what Hamilton operator and psi, that H psi is equals to E psi. Simply children, remember one thing, Schrodinger gave a wave equation. Schrodinger gave a wave equation that depends upon he considered a electron as a standing wave. Standing wave means the wave will be there only, it will not move further. That means the starting and ending position of the ending point of the wave will be similar, right? So by this way you can quantize. Quantize means you can say quantity. Quantize means quantity, number of waves you can say, right? So here we can say the number of waves, right? Here we can say the number of waves. That means energy we are quantizing. We are quantizing the energy, right? So that we can measure the energy of the system. For that measuring, we need to where, the electron is where it is moving. The things we need. It is moving in the x-axis, it is moving in the y-axis, it is moving in the z-axis. 3-dimensionally it is moving. So that 3-dimensionally we calculate the energy. That is Schrodinger calculated the energy by using a formula called this one, right? In x-axis how it is behaving, that is dou square psi by dou x square, in y and in z, and the total energy is given. So apart from this, you can remember it easily by H cap psi is equals to E cap. H cap psi is equals to E psi, right? That is what Schrodinger's wave equation. And this thing, this explanation is basic for the further topics like Bohr model and the orbits, all these things based on this Schrodinger's wave equation only. So we consider this Schrodinger wave equation is the basic step towards the explanation of the structure of atom, right? So that is regarding the Schrodinger's wave equation, right?